In this question, I just played around with it for a little while and I didn't directly get to the answer. So I'm going to talk about what I actually tried to do. We've got x squared plus bx plus c equals 0, and we're interested in it having integer solutions. Now, that actually means that we can factorize it. So maybe x plus alpha times x plus beta equals 0. And I then expanded it, which gives me alpha plus beta x plus alpha beta, in which we can see that this is b and this is C. I didn't actually pay any attention to that at the time, but I'm going to come back to why actually that is really useful at this point. Maybe you can already see it. But I wrote that down anyway, but I didn't do anything with it. I then went into using the quadratic formula, which you may or may not have covered. So for us to get integer solutions, it is necessary that b squared minus 4ac is a square number. I then kind of factorize that because I can treat it as a difference of two squares and write b plus 2 root c and b minus 2 root c. Then I did look at it and thought, like, that looks really complicated. How on earth am I going to use that? And also, although it's going to be a requirement, I don't think it's sufficient because we're still dividing through by 2. So you might get an answer of, say, 3 for your numerator and then divide by 2 and you won't actually get a whole number. So that way doesn't seem to be like a good way. So what else but to just maybe write down some quadratics that have, um, you know, integer solutions. And this is what when I get people to factorize, I always go with this one as quite a nice one, just a very simple one where the answers actually just differ by 1. And that got me thinking, and I thought, okay, x squared plus 2x plus 1 is then x plus 1 squared. So I've managed to get um, I've managed to get 5 and 6, so which are consecutive, and 2 and 1 that are consecutive. So can we get some more? Is there a way to do this where the numbers are consecutive? Right, well, what about x squared? And you can even kind of start with you can start with the factorized form if it helps. So maybe x plus 25 and x plus 4. That will give me x squared plus 29x plus 100. Now that didn't really help because it doesn't quite fit my pattern. So I kind of erased that and then went back to, okay, what about x? I'm doing this from memory, by the way. Like I can't quite remember what I did at the time. I'm trying to go through the same process. So that gives x squared plus 32x plus 31. And this seems to have hit on something because I've got another consecutive pair. Um, And now I can see that I can use 1 and 31. So when I times these, I'm going to get 31. And when I add them, I'm going to get 32. So can we generalize it? I did one more actually. So x squared plus 100x plus 99 gives x plus 99 times x plus 1. And I think at this point I was like, yeah, I've got it. Because if we have x squared plus a plus 1x plus a, then we can factorize it actually as x plus 1 times x plus a. This will necessarily factorize if you have a number for a and then the next integer after it for b. And so we compare up 2 and 1. Do I want to put it in brackets? I don't know, just to show that I'm pairing them up. 4 and 3, and so on, up to 199. since each of these pairs are in the form a plus 1a. And therefore it's possible to erase all the numbers. That is actually it. The hardest bit is getting to this idea, because once you've got the idea, the solution just comes together very quickly. Remember, we're crossing off the numbers as we go and we're trying to write them all down. Actually, if we return to the very start of the question, I kind of had it was there all along. If I just let, say, beta equal 1, then I would get alpha plus 1 here, and I would get alpha here. So that the condition's there, and then I'd be necessarily able to factorize it as this. It's just I wasn't thinking along those lines at the time, but just in hindsight, I can see it was there. But I'm just trying to show you how I did do it, kind of with examples. But this is the main idea, that you have to spot the fact that you can. I mean, maybe there's other ways to do this question, but this seems like the simplest if you're just using consecutive pairs. I can't even imagine how else you would do it to ensure that you would get all 100. But yeah, x squared plus a plus 1x plus a can be factorized like this. So we can just pair them up one after another, 2 and 1, 4 and 3. I hope that makes sense. And that means as we can cross them out, because we've got 1 to 100, so we just cross out 1 and 2 and 3 and 4 and so on until we necessarily erase all the numbers. Nice.